Today, I'm going to talk about a use case that we've been seeing pop up a lot in Leostream environments. I always kind of joke that Leostream isn't necessarily a VDI company. We can do VDI, but there's a lot of other use cases that you can satisfy as well. And one of them is using Leostream to manage high performance compute. And as I mentioned, we see this a lot lately. Now, the thing that I want to point out is there are tools out there for managing high performance compute, and it's all about scheduling. People submit jobs to a queue, and then those jobs get scheduled out amongst your servers. That's not the kind of tool that Leostream is. We're not a scheduling for the jobs themselves. What we are is a management tool for the entire environment, basically giving you ways to manage the access and the capacity in your high performance compute, whether that be in the cloud or on-prem. So why would you want to add Leostream into the mix for HPC environments? Well, for one, because of the vendor neutrality of the Leostream platform, you can leverage the hosting platform that's best for your HPC cluster. So whether that be a bunch of racked workstations, or maybe virtualization in VMware, Red Hat, what have you, or it could also be up in the cloud. It could be OpenStack, Azure, AWS, Google Cloud Platform, wherever you want to host your cluster, and perhaps it's across different platforms, you can do that and manage the capacity using Leostream. Then in Leostream, what you do once you've determined where you're going to host your HPC clusters is you create pools in Leostream for these clusters, and then you control access to those pools. Again, it's not submitting the jobs on the pools, but it's actually access to the compute itself. So you can do this based on time of day, day of the week, and I'll show you some of that in the demo coming up here. Now, we talk about compute, and obviously there's a lot of data processing that's going on in the background, but at some point in time, somebody needs to log in and visualize the data that they've churned out. And with Leostream, you can connect users to your servers or your VMs using any number of high performance display protocols. So depending on what types of applications that you're using to visualize the data, sometimes you care more about perfect color, sometimes it's about accurate movements for 3D models. You can leverage the high performance display protocol that's appropriate, because they are different and usually specialize in different aspects of the connection. The last point I have here, and I'll show you in this demo that's coming up right now, is with Leostream, you can really automate the capacity for your HPC environment. So the idea is, if you have more users who need to access the environment and run more jobs, you can have Leostream automatically scale out and then scale back in your environment when they're done. So really, that's important, particularly if you're running in the public cloud, because you're going to pay for that compute, and these are usually large instances that are pretty pricey, and you're going to pay for them while they're running and why they exist. And so you want tools that automate this so you don't have to constantly be watching. So to show you some of the features specifically in Leostream that target these points right here. Sorry, as I share my screen, let me come here. So I'm going to show you an environment that actually spans a couple clouds. And so what you see here is I have some instances running in AWS. My broker is actually running there, as is my Leostream gateway. And then I have a small HPC cluster running here that the broker actually automatically spun up for me about a half hour before this demo started. I'll show you how I scheduled that. And then I have one simple machine running up in Azure, and this is a Linux box, happens to be Ubuntu, that's running Skilled Cloud Workstation. This is a new display protocol that we're in the process of adding into Leostream, and it's great because it has an in-browser option, which I'll show you, and that in-browser option can actually even span multiple monitors, and they do have a client-based system as well. I should point out that my HPC cluster that's running here in AWS is running the nice DCV software, because that's great, because one, it is highly performant. The other, it comes free with my AWS compute costs. So it gives you a way to leverage high performance compute and get high performant graphics, all just wrapped into AWS. So here is my connection broker. I'm going to log in. This is the main administrator interface, and I'll show you here in a bit what it looks like from an end user perspective, but I'm going to log in as the main admin. Now, I won't step through this entire interface. Let me just show you how I hooked up to my existing environment and some of the aspects that demonstrate the points I made earlier. Here in the setup section, this is where you hook us up to all the other external systems in your environment, various different ways you can authenticate. And then in centers, this is where I've connected to my different cloud environments. So here I've created a center for AWS. I have one also for Azure. These types of centers, the ones for the clouds and the virtualization environments, they leverage the native APIs for those environments to manage those clouds. So this is why we can quickly and easily power control machines, deallocate them in the case of Azure. And we can also control the capacity, launch new instances, terminate them when people are done. I have this other center type here, this DCV virtual sessions, for if you are running some Linux servers that have the nice DCV software on that is multi-user, is capable of doing multi-user sessions. And so we have a special center for handling that. You would essentially tell us how many users are allowed to access this particular server simultaneously, and then they get unique sessions on that server. So this is great if you do have one really large compute node and you want multiple people to be able to access it simultaneously. You can do that using a multi-user center and the nice DCV protocol. So that's all I'm going to cover in the setup section. Let's go down and look at configuration. And a lot of what I want to talk about is pools. So if I look at my list of pools here, let me highlight a couple. One, I did create just a pool here of, this is everything that's in my Azure region. A center for Azure is basically everything in a particular region. So this gives me an organizational tool here. I've created everything in Azure East. And then because my skilled machine is running in there, I've created another pool which contains just that skilled cloud workstation that we'll connect to. So just pointing that out. And then here, my Linux HPC machines, this is that HPC cluster that I had up in AWS. So if I look at the way this pool is configured, the pool definition always defines what machines are in the pool, and it's very dynamic. So if you go into your virtualization or cloud environment and create new machines, when we scan the center, we'll pick those new machines up and sort them into the appropriate pools for you. Here I'm doing it based on machine name. So any machine that starts with HPC. What you see now is there's two, which are those two machines you saw in AWS earlier. Those machines, as I mentioned, were actually provisioned automatically by Leostream about a half hour or so ago. And that's done in this provisioning section down here. So nominally, there's no machines in this pool. If no one's working, I don't want machines running up in the cloud. I don't want them even existing in the cloud. So by default, my pool is set to 0. Well, to prep for this particular demo, I wanted to enforce new provisioning limits during this time frame. And that's what you see down here in this table. This row that's green right now, this is the current time. And that's my connection brokers database time is what that's using. This is when I was testing it yesterday. So now I'm running within this time zone here. So it automatically created those two machines, and it's not going to create any more than 2. So this allows me to make sure I don't over allocate the cloud. You usually have quotas that you have up in the cloud, and you don't want us to try and provision over that. You could make this higher than the start, and then we'd provision more as users log in. So this gives me a way to make sure compute only exists during the time frame people actually need it. The provisioning parameters section here, this then tells us how do we want to provision these machines. So I'm provisioning AWS. There you see my naming convention, I should say, so that I can guarantee these desktops end up in this pool. And then I select the image that I want to deploy from. So here's where you want to make sure that image has whatever software you need to do your compute and your analysis, as well as the Leostream agent. It's very important that these images always have the Leostream agent on them, because that agent is going to report back information to the broker and allow you to control the user's session. Now I'm running obviously a T2 medium, not very high performance compute ready, but we do support the ability to launch any instance size. As new instances are available, instance sizes available in Azure and AWS, we'll add them to this list. So if you need one and you don't see it, just drop us a line. It's very easy for us to add. And then obviously the rest of the parameters, just the networks and the security groups. And then here I've marked the machine deletable. And that's important in this particular use case, because what's going to happen is at the end of this time frame, I want to return to my nominal values of 0. So at 4:30, as long as these machines are not in use, the broker is going to power down and terminate them. So there's my pools. What I want to do now is offer users a connection to the Skilled Cloud Workstation as well as one of the Linux HPC machines. Before I do that, I need to create a couple protocol plans so I can connect appropriately based on what the machine actually supports. So I have two protocol plans in here that are important. Here I'm launching a connection through a web browser to the Skilled HTML5 viewer. That can go through the gateway, it doesn't have to. In my case, my Azure machine has a public IP address, so I'm not going to pass it through the gateway, but you could. We're in the process of adding support. You'll notice right now, Leostream Connect is our software client. It installs on Windows, Linux, Mac. Right now, there is no option in there for launching the Skilled Cloud Workstation software client, but that, as well as additional Leostream agent reporting for Skilled Cloud Workstation, is coming in a release later in a couple months. So there's my protocol plan to launch the Skilled Cloud Workstation HTML5 viewer. And then I have, I believe it's this one I want to look at. I have a protocol plan that's launching DCV. DCV is supported both client-based as well as client from the web or HTML5 from the web. In this case, just to show you something a little different, I'm going to actually launch the DCV software client from the web browser. So this way you can see both a client-based and an HTML5-based connection. So let me quickly show you the release plan that I'm going to use here. So for that high performance, my HPC cluster, I want someone to be able to log in to the machine, run some calculations, do some visualization, do whatever they need to do. And then when they're done, what I want to happen is that machine to get deleted, to be terminated, and a new one spun up. So there's a clean one for the next user. So I have this delete on logout release plan here. Essentially what it's saying is if the user disconnects, very likely with these HPC jobs, they usually run for a while. So someone logs in, they kick off the job, and then they disconnect, and they just let it run in the background. So I don't want the disconnect to forcefully log the user out or release the machine to a pool. It's doing something. But now when the user logs out, that generally is an indicator that they're done. So I'm going to go ahead and release the pool. What I could also say here is I could set something on idle. So if the machine is idle for an hour, but I'm going to suspend that based on CPU. So if I know the jobs that they're running tend to take an amount of time and take up a certain amount of CPU, I can watch for that and then automatically log the user out when that job is done as well. So here, it's the logout, it's releasing the machine to the pool. So if idle causes logout, logout will cause the release. Release then says, go ahead and immediately delete this machine from the pool. What'll happen then is the broker will notice, oh, I'm supposed to have two machines in the pool right now. I only have one because I deleted one. So it'll go ahead and spin up a nice brand new one for the next user. Just to show you this all in policy. So here I have the policy that the user is going to be offered. It's going to offer one machine from that HPC pool and launch it using DCV with the delete on logout release plan. And then I've got my Skilled Cloud Workstation pool. So I'm going to offer one machine from Skilled Cloud Workstations. Now here is the other way that you can do management for your HPC cluster. It might be that you only want the compute to exist at a certain amount of time. It could be that these machines are already there, especially if they're physical, and you just want to control when users have access to them. So if this is a cluster that people can submit HPC jobs to overnight, but other users can access for various other tasks during the day, then you can create policies that only give access to that pool during the appropriate times. And that's what you have here. I have a policy that offers, in this case, all users, but only access during today's time frame. So right now. So this policy, just to quickly show you, this policies generally get assigned to users through their Active Directory attributes, or I should say authentication server attributes. In my case, it is AD. So here I'm going to show you a web browser login. So anyone right now, for my case, who logs in from a web browser, they're going to get that HPC, DCV, and Skilled Cloud Workstation role. Before I show you the actual login, something that's very cool that people love and really helps when you're setting up your environment is this test login functionality. So even before users log in, I can come in here and test the login, and I can even pick the particular time of day. So today is Thursday. It is around, say, 3:15. So here I can see, okay, if users start logging in at that time, do they get the appropriate things? And sure enough, I get my one HPC machine and my skilled cloud workstation machine. So to see that, here is what an end user sees. So there's the two machines that I have. Let's go ahead and connect to the skilled machine. This is going to launch the HTML5 viewer. It does launch in a new tab because my policy asked it to do so. And then that'll connect in. Now, we're still working on the single sign-on for the cloud workstation. So this will prompt me for a username and password and then log me into the system there. While that's going on, I can come over here and connect to Nice DCV. So now you see the DCV client launching. What's happening in the background is the Leostream agent is actually starting the DCV session for the user and then logging them into that machine. Now, while all this is going on here, let me just minimize this. In the background here in the broker, you see everything happening over here on the system logs page. So I can see when users are being assigned to the machines. That's the assignment happened because I requested the connection, so I was assigned. You notice in that case, remember my limits on my pool were set so that there were a maximum of 2 allowed. So even though I grabbed one, I was now assigned. The broker's not going to provision anymore because I was already at the max number of 2. And then it went ahead and added the forwarding rule to the gateway because that protocol plan for DCV was actually tunneled through the gateway. You see the agent notifications coming in, tells me when I was connected, when I've actually logged in. So all this information is here for you to use and track who's using what from where and for how long. Now, if I go ahead here and log out of this machine, yep. So the logout, the agent's going to notify the broker of the logout. And then because of the way my release plan was set up, it's going to go ahead and terminate the machine. And you'll see there's removing the forwarding port from the Leostream gateway. That's good for security. You want to make sure those ports are only forwarded at the time somebody is using that connection. And then it deleted the machine. The delete now the pool really does only have one machine left in it. And so that triggered off a new provisioning. So I can see new machines being created over here in AWS as this is all going on. So refresh that. And you see the HPC5 being spun up. The older machines are now terminated. So that is generally the demo. There's a lot of other features and functionalities in there. If you want to give this a try, we do provide a free trial, so you can feel free to contact us at sales@leostream.com and we can provide you with more information. Thanks. Bye.